In this session, we're going to look at how we can create transitions using the out-of-the-box Civil 3D subassembly components. So using this technique, we can transition thicknesses, widths, slopes, virtually any object. And we're going to do it just by creating a number generator that's going to calculate the transitions for us. I'll show you what I mean. We're going to start by going to Subassembly Composer. I'm going to do that by jumping down to the start area here, and I'll start typing Subassembly Composer. We'll bring that up on screen. And then I'm going to create just a really simple part that's going to calculate my transitions for me. So I'm going to start here on the Packet Settings tab, and I'm going to call this Number Generator. And we'll say this, the purpose for this subassembly part is calculates values for transitions. I will then come down to target parameter. Now the way it's going to calculate the numbers, it's going to be visual. We're going to be using a profile in this case. So for that reason, I'm going to go to create parameter, and for type, I'll set this to elevation or a profile target. I will then call this numeric control line. Perfect. For display name, I'll just call this NCL. All right, one more thing. I need to create an output parameter because I want this to be this number that it comes up with. I need to pass that to another subassembly dimension. So we're going to create an output parameter, and as long as we're on this tab, let's set the default value for the subassembly part. I'm going to set that to right. So this way, each time we drop this in brand new, it's going to want to go by default to the right side. Now let's create a parameter, the output parameter. I will call this output parameter. This is going to be double. Direction is going to be output. Perfect. That's it. One more thing. I am going to create a set output parameter. Let me drag this into the flow chart here. And what I'm going to do is essentially create a set parameter that says, take this output parameter and grab the value or the elevational value from my profile or from my numeric control line. Now, the way this works, I'm going to be entering a VB expression, Visual Basic Expression. If I go to Help, let me click Help and I'll choose View Help. We can find these if I go to entering or calculating property data under API functions, under elevational or elevation target class. I'm just going to enter this code right here. That's all I have to do. So what's the name of that target? And then I want to extract its elevation. Let me close this. So output parameter. What output parameter do I want to set that do I want to assign? Well, I've got this one that I created called output parameter. And what value do I want to assign to it? I want to assign numeric control line dot elevation. Perfect. That's it. That's all we have to do. Let's do a save as. And I'm going to save this in a test PKT folder on my desktop. I'm going to call this number generator. Now, let's go to Civil 3D. Over here, I've got just a simple corridor that was created. I've got an alignment here called Main Street. If I come over to the right, I've got a profile view, and Main Street has a finished grade profile. It also has a surface profile for the existing ground. If I come up to the top here, we can see that I've created an assembly. That assembly is called Main Street, and it is using two of the basic subassembly parts, basic lane, and then we've got the urban curb gutter general. Let's say that I would like to transition the width of the flow line or the flange here of the curb and gutter. If I bring up the tool palette and I go to curbs, here's that urban curb gutter general. If I right click on this and choose help, I can see that there is a property, dimension B is what actually controls that. Now if I drag this down under targets, you can see target parameters. This doesn't support any targets. That's the nice thing about this workflow is I don't have to create the targets. I'm just going to be passing numbers to this, updating these dimensions. So dimension B is the one I want to change. Let me close this. Just to test that, if I select that part and go to the Properties palette and come down to dimension B, I can see that that's set to about a foot. If I set that to about 1.5 feet or 18 inches, if I press enter, you can see how that changes. So let's set that back to 12. Perfect. All right, so I want to be able to drive or transition that width, and this part doesn't support that. So what I'm going to use is I'll be using my number generator. Let me create a custom palette here. I'm going to right-click on one of these tabs and choose New Palette, and I'll call this My Custom. I can then right-click on that, the new palette I created, and choose Import Subassemblies. And then we'll jump into that test PKT folder, and we'll grab the number generator that I just made, and I'll click Open, and then I'll click OK. So there it is. Now, let's add this to my assembly. We'll say we're just going to be transitioning the right side in this case. I'll select that, and then I'm going to choose Insert. I want to insert it before an object. I want to insert this before the lane. Let me press Escape. If I hover over my little number generator, you can see it's displayed as a couple of rings on screen. Let me select that, and I'll go over to the Properties palette, and I can rename this. This because I can have several of these number generators in here, each driving different aspects of the assembly if I want. For right now, I'm going to call this Curb Gutter Flange Transition. And then I'm going to come down to the default loop offset. That's 10 feet. Let me set that to 0.5 foot. You can see how that jumped over. I'll press Escape, and I'll do a quick regen. Now, I could set that to 0 if I wanted to, and you'd never even see the thing. If I did that, I wouldn't be able to easily select it on screen, especially if I had a bunch of them. That said, I could always select the assembly and go to Assembly Properties, and I could select the thing from here if I wanted to, and I could adjust, properties and things like that. Let me close this. So what I'm going to do, let's set this, one more thing. I'll select that, and I'll come over, Output Parameter. What's the default number here? Well, I'm going to set this, instead of 0, I'm going to set this to 1 foot. I'll just type 1 and hit Enter. I do that because I am going to select the assembly. I'll go to Assembly Properties and under Construction. So here's the right side of my assembly. There's the curb and gutter. I'm going to come down and find dimension B, which is 12 inches or a foot by default. Instead of using that measurement, I'm going to say I want you to use a parameter. Which parameter? I want you to use the curb gutter flange transition, or my number generator, for that particular part. And when I select that and click OK, this is now looking at this for its value. That's why I had to give it a value and other than 0, otherwise you end up getting an error because I can't have a curb gutter with a width of 0. So this particular dimension is now looking at this object for its value. Let's take it one step further. I'm going to close this. I can now create some profile geometry that I could use to drive the transitions for this. Let's pan this over. Currently I've got a profile view for Main Street. Let me select that, and I'll go to Profile View Properties. And currently, this is set to automatic height. I'm going to set that to user specified. So it's not going to change at all. Let me click OK. I do that because I'm going to create a second profile view. Let me choose Copy. And I will copy this profile view down. I will then select this version. I'll go to Profile View Properties, and I'm going to change its height. I'm going to set this to -20 for my datum, or bottom, if you will, and I want this to have a height of maybe 10. Okay, so this profile view is showing me the same thing, but we're way down at elevation 0. And remember, this isn't really a profile that we're creating here. It's basically a numeric control line. It's generating numbers for me. So let's create a profile now to generate the numbers for that flange. I'll do that by selecting the view, and then I'll go to Profile Creation Tools, and I'm going to call this Curb Gutter Flange Target. Or we'll call it Flange Value. There we go. Let me click OK, and then I know that I want this to run the full length of the alignment, so I'm just going to grab the beginning of the profile view, and I'll take this down nearest, and I'll grab the end. And then I'll bring up the tabular editor, and we'll set this so that that number is 1, and it'll be 1 from the beginning to the end. Okay, let me close this. So now, if I come over to my corridor, I can select this. We can go to Edit Targets, and I'll choose the corridor. And here we can see my number generator that I renamed curb gutter transition, flange transition. It wants to know, where do you want me to look to get that number? I am going to have you look at the flange values profile. I'll click Add, and I'll click OK. So that profile is passing numbers to that subassembly part. That value is then an output value, which is being passed to the flange. Let's click OK. And we don't see a change because all the numbers are the same at this point. It's still a 12-inch or a 1-foot flange. But now, let me hit Escape. Now, if I come over here, I can just edit this. So it's kind of like a visual for my transitions. So I'm doing it with a linear object. If I select this profile, I can go to Geometry Editor. Let's add a PVI, and then I'm going to add that by station elevation. I'll grab my profile view, and let's say that it's station 100. It's going to have a width of 1 foot. Okay, and then at 200, it's going to have a width of 1.5 or 18 inches. We'll carry that to 300. We'll make that 1.5. And then maybe at 400, we'll knock that down to half a foot. We'll go to 500. We'll transition from 400 to 500. We'll transition back up to a foot. All right, perfect. So I can use this now as a means of calculating the transitions that'll be passed to my assembly, which will then be passed to my corridor. Let's come over to the corridor, and I'll select this, and then I will rebuild. We can see the change there, slight. Let me select the profile view or the subassembly, and I'll go to Section Editor. And we'll change the view here. We'll put the section view on top, and then maybe we'll put the plan view in the lower right. That's better. So as I start stepping through this now, I think for the first 100 feet we maintain a 12-inch flange on that curb. But then once we get out, you can see how that's expanding to 1.5 feet. It holds that, and then we'll transition back down to 0.5 foot, and then we transition back out to 1 foot. Okay, when I'm finished, I'll hit close. So now I'm taking and just using that number generator as a means of driving the dimensions of the parts that are already available out of the box in Civil 3D. The nice thing is I can have as many of those number generators as I want. I could keep bringing those in, dropping them. You always want to drop them to the inside as close to the beginning of the assembly as possible, because that way the objects that are to the right or to the left, depending on how they're inserted, you can have them look at the one that's prior to it to calculate that, or to grab the number. And like I said, the nice thing about this workflow is, since it's just a number generator, I can use this to drive pavement thicknesses. I can use it to drive widths. I can use it to drive slopes if I want to. So just another concept. Please let me know if this might be helpful. Thanks a lot. See ya.